Mass wasting is a powerful natural process that reshapes the Earth's surface by moving soil, rock, and debris downslope under the influence of gravity. Unlike other processes that depend on agents like water or wind, mass wasting relies solely on gravity. It plays a key role in forming and transforming landscape from slowing moving soil creep to sudden landslide that can dramatically alter terrain. This process is influenced by factors like slope steepness, material type, vegetation cover, and water content. Events like heavy rainfall or human activity, such as deforestation or construction, can destabilize slope and trigger mass wasting. These movements can have significant impacts, including the destruction or instruction loss of life and changes to ecosystem. In this activity, we aim to explore the mechanism and effects of mass wasting through experimentation. By observing how slope, fill, and debris move, we'll gain insight into real world example such as landslide into mountainous area and discuss how mitigate their impacts. This understanding is crucial for managing risks and promoting sustainable land use in vulnerable regions.
To demonstrate what mass wasting is as an exogenic process, we will use the following materials. First, we need an aluminum tray to contain our sections. We have three sections. First is our sand, second is our loamy soil, and lastly, we have our rocky soil. Now, to demonstrate what happens in mass wasting, we will tilt the container or tray in various degrees. First, we have our control setting, 0-degree tilting. As we can see, no sediments have gone through the other side as to where the holes are located. Next, 40 degrees tilting. As we can see, there has been some sediments that have passed through the holes, but not much. Third, we have our 60-degree tilting. We can notice that it is much more compared to the past few degrees. And lastly, we have our 80-degree tilting, where this has displayed the most sediments released through the gaps, and thus we can hypothesize and conclude that the steeper the slope, the more sediments or the more likely mass wasting is going to happen. The falling of debris or sediments, as demonstrated through the gaps, can be compared to landslides and rock flows that happens in these types of scenarios. This can cause loss of life or property destruction to those who are near.
Mass wasting can be classified into three categories: flow, slide, and fall. For the first category, flow, we have soil creep, debris flow, mud flow, and avalanche. Here is an example of soil creep in Oregon, USA. And here is another example in Egerton Hill in Dorset, England in the UK. For debris flow and mud flow, here is an example from Montecito, California in January 2018. And for avalanche, we have the 1970 Huascaran avalanche in Yungay, Peru. For slide, the second category, we have rock slide and landslide. Here is an example of a rock slide, the Highway 64 rock slide in Tennessee, USA in 2009. For landslide, we have the Mairato landslide in Calabria, Italy in 2010. And lastly, fall. The third category, we have rockfall. In this picture is a rockfall in Yosemite National Park in California, USA in 2017.
Because of the many hazards that mass wasting showcases, like damage to human life, animal life, and infrastructure, mitigation procedures for mass wasting is important. Now, some of these examples are forestation, which is the planting of trees to help bind the soil from moving. And next is terracing, which is the shaping of slopes into steps. And the drainage controls, which is draining water away from slide areas. Now these are only some examples of mitigation processes.